Hello, students. In our first lesson, we looked at solving linear equations, and each of those equations had one variable. So before, we considered equations that looked something like 3x plus 2 equals 20. Now, to solve that equation, we could subtract 2 and then divide by 3 to get x by itself. If you were to go through and solve that equation, you would end up with x equals 6 as your solution. But now we're going to be looking at equations that have two variables in them. For example, y equals negative 1/2 x plus 2. If we're looking at an equation like this, we're not going to have solutions that look like x equals 6. Why is that? Well, in this equation, we don't just have x as a variable, but we also have y. So a solution to this equation is going to have a value for x and a value for y. One way that we can find solutions to this equation is we can pick values for x and then plug them in and solve for y and figure out what the corresponding values are for y. Now we can actually pick any number we want for x and then multiply it by negative 1/2 and add 2 and then figure out a corresponding value of y. What we're going to do is we're going to pick values of x that make these calculations easier. Because x is being multiplied by negative 1/2, it's going to be easier to pick values of x that are even, or multiples of 2. Because if x is even, or a multiple of 2, when we multiply it by negative 1/2, we'll still get an integer. We'll end up with no more fractions, and that makes life easier. So for my values of x, I'm going to pick 2 and 4. I'll pick 0. 0 is always a good number to pick. And then I'm going to pick negative 2 and negative 4. We generally want some positive numbers and negative numbers so that we can get a nice range of solutions. So what we're going to do, and I'm going to make another column here, is we're going to actually plug in these values of x and then figure out what y is. So if x is 2, then y is negative 1/2 times 2 plus 2. I'm just taking the value of x and plugging it in to the equation. Now we can do the math. Negative 1/2 times 2 is negative 1. So this becomes negative 1 plus 2, which is positive 1. And then we can go through and plug in 4. That's going to give us negative 1/2 times 4 plus 2. Negative 1/2 times 4 is negative 2, and negative 2 plus 2 is 0. So then when x is 4, y is 0. We can continue. When we plug in 0, that's negative 1/2 times 0 plus 2. Anything times 0 is 0, and 0 plus 2 is 2. Now let's plug in the negative numbers. When we plug in negative 2, we recognize that a negative times a negative is positive, so that negative 1/2 times negative 2 is going to be positive 1, and positive 1 plus 2 is 3. And then we're going to plug in negative 4. Negative 1/2 times negative 4 is positive 2, and 2 plus 2 is 4. So we have already 5 solutions. Each one of them has a value for x and a value for y. Are these the only 5 solutions? Well, no, they're not. We only ended up with these 5 because we picked these 5 values for x. How many solutions will there be in total? Well, any value of x we can plug in, multiply by negative 1/2 and add 2. So we could go on forever picking more and more values of x. They don't even have to be integers. They could be fractions or decimals. And so really there are an infinite number of solutions because we can pick an infinite number of x's and for each one of those, figure out the corresponding value for y. We don't want to plug in an infinite number of values of x though, because we'll be here forever. And you don't want to spend the rest of your life solving one math problem. I love math, and I don't want to spend the rest of my life solving one math problem. So we need another way to figure out how to represent the solutions. And one thing we notice is that because each solution has a value for x and a value for y, each of these corresponds to a point in the xy plane. Here's the xy plane. What I'm going to do is I'm going to take each of these points and plot them on the plane. Let's start with 2, 1. That has an x value of 2 and a y value of 1. So it's to the right 2 and up 1. It's going to go there. The next one is 4, 0. That's going to be to the right 4 and up 0. So that's going to go here. Then we have 0, 2. That's to the right 0 and up 2. That's going to go right there. Then we have negative 2, 3. That's to the left 2 and up 3. It's going to go right there. And then our fifth one is negative 4, 4. So that's to the left 4 and up 4. That's going to go right there. And if we look at these points, we notice that they have something in common. All of these points are on the same line. And in fact, if we were to make more x values, to choose more x values and find the corresponding y values, we would see that all of the solutions fall on this same line. And in fact, every point on this line represents a solution. We said there are infinitely many solutions to this equation. There are also infinitely many points on this line, and every point on the line corresponds to one of the solutions. So this is a way that we can represent an infinite number of solutions without having to do an infinite number of calculations. We can draw in the line that represents those solutions, and then we're going to label this line with the equation that it represents, y equals negative 1/2 x plus 2. Whenever we have an equation with x and y, we can represent the solutions to that equation by the graph. And all of the examples that we're going to be looking at today and in the next lesson are going to end up being lines. They are linear equations, which means the x and the y's don't have any exponents, and we don't have any other crazy things going on, like absolute values or variables and denominators, etc. Now, let's take a look at another example. Let's sketch a graph of 3x plus 4y equals 8. In general, when we have an equation like this, it's not going to say solve 3x plus 4y equals 8. It's going to say sketch a graph of 3x plus 4y equals 8, which basically means we're representing all of the solutions graphically. This one is a little bit different from the last example. With the last example, y was already isolated, and so it was easy to do the calculations and figure out what y would be for each value of x. Here, this is not the case. We could just start by plugging in values for x and then solving for y, but our life is going to be much easier if we isolate the y first, like it is in the other example, and then we set up our table of values. So the first thing we're going to do is we're going to get that y alone. So I am going to rewrite the equation over here, 3x plus 4y equals 8, and we want to isolate the y. So the first thing we're going to do is we want to get rid of this 3x term. We're going to do that by subtracting 3x from both sides. That gives us 4y equals 8 minus 3x. Now to get the y alone, we need to get rid of the 4, and we can do that by dividing each side by 4. And I'm going to divide each term by 4 individually. This leaves us with y equals 8 divided by 4 is 2, and then minus 3/4 x. This is an equivalent version of this same equation, but now we've isolated y, which is going to make things easier for our table of values. So I'm going to set up the table of values here. We're going to pick values for x and then find corresponding values for y. Now we could pick anything we want for x, but because x is being multiplied by 3/4, to get rid of the fractions, it's going to be easier if we pick x to be a multiple of 4. So we can pick 4 and 8, 0 always works, and then -4 and -8. I like to always pick at least 5 x values to get 5 points, because if we only pick 2 or 3 and we make a mistake somewhere, it might not be so easy to see our mistake. But if we have 5 points and we plot them and they're not in a line, one of them is somewhere off in the wrong place, that tells us that we've likely made a mistake. So let's go through and let's plug in our values for x and figure out the corresponding values for y. In fact, you could pause the video now and do this on your own, and then afterwards check to see if you've done it correctly. That's probably better than just watching me do all of it. So pause the video if you like here. I'm going to continue. We know that y is 2 minus 3/4 of x. If x is 4, this is 2 minus 3/4 times 4. Well, 3/4 times 4 is 3. The 4's cancel. So this becomes 2 minus 3, which is -1. If we plug in 8, 3/4 of 8 is 6. So this becomes 2 minus 6, which is going to be -4. If we plug in 0, anything times 0 is 0. So we've got 2 minus 0, which is 2. If we plug in -4, a negative times a negative is positive, so it's going to be 2 plus. And here those 4's cancel out, leaving us with 3. 2 plus 3 is 5. And then if we plug in -8, again, the negatives cancel to give us a positive, and 3/4 of 8 is 6, so 2 plus 6 is 8, and we've got our points. Let's plot these on the xy plane. Our first point is 4, -1, so we go to the right 4 and down 1, and our point is going to go there. The next point is 8, -4, so we go to the right 8 and then down 4, and our point is going to go there. Let's see, that's right here. The third point is 0, 2, so we go to the right 0 and up 2. Our point is going to be here. The fourth point, -4, 5, is to the left 4 and up 5. That's going to be here. The fifth point, -8, 8, is to the left 8 and up 8. That's going to be here. Again, our points are on the same line, so it looks like we've done things correctly. We connect the dots with a straight line. If you're doing this by hand, I would recommend using a ruler. A ruler doesn't work super well on my iPad, so I'm doing my best to draw straight lines by hand. If you were to draw something like this on a test, this is close enough. It looks fine. And so this is the line that represents the solutions to 3x plus 4y equals 8. I'm going to label it like that, and then we have our line. The link below gives more examples of graphing linear equations using the tables of values, which is what we've been doing here. In the next video, we're going to learn a second method for graphing these lines, which is called the intercept method. And then in our next lesson, we're going to learn a third method, which is called slope-intercept form. It's important to learn all three methods because each of these methods is useful in a different scenario. We'll use all three of these later on in the semester. And they also involve looking at these lines in slightly different ways. And it's always good to be able to look at something from different perspectives because then when you want to adapt it into some new method, you've got multiple starting points and you've got more options.